video, we're going to talk about product sum factoring. So that only works with a specific type of polynomial. So if we have a trinomial or three pieces like this is something that we can try. I know that's not always going to work out, but it's helpful when we do have something like this and we can avoid quadratic formula, something like that. I have two different ones listed out that I'm hoping to get through, just because we'll see a little bit of a twist between the two, a little bit of a difference. Like I said, for these problems, you're going to have three separate terms going on, and they're each going to play a role with how we set up this problem. So let's start on this one now. Product sum in the name of the type of factoring, that ties in product, so the answer we get when we multiply something, and sum, so what we get when we add two things together, or add anything together. In this case, we're going to get a p-value and an s-value that's going to lead us into our different factoring. To get the product, we multiply our leading coefficient, so the very first number you see, by the constant at the end. So that's going to be a 2 and a 7 in this case, and we're going to get 14. Sum is significantly easier. It's just the b value or the middle number, so that's a 9. What we need to think about now is we have to come up with two numbers that multiply to get 14 and add to get 9. So for some that's kind of obvious, and for some it's not. So what I like to do is, if I'm not sure, list all the different factors. So 1 and 14, 2 and 7. And don't forget that we can have double negatives of each, because two negatives make a positive. That also works out. But in this case, this is the pair that we're going to choose, because 2 and 7 multiply to get 14 and add to get 9. So once we've selected that, we can keep going. And you'll probably hear that there's a, my board is smearing, that's there. Probably hear that there's a shortcut kind of version to this. That only works if this first leading coefficient, that first number, is a 1. In this case it's not, so we do have a lengthier problem here. So we chose 2 and 7, so what we're going to do is we're going to rewrite our initial expression, but we're going to start to split the middle term, and it's like we're undoing like terms. So think about factoring as in we're working distribution backwards. This specific step here is like working like terms backwards. So we're going to split, instead of a 9, we're going to have a 2j plus 7j, and then we're going to finish off the expression like it was before. Now that we have 4 terms here, we can get into factoring by grouping, which is not always its own sort of factoring, but basically it's anytime you have 4 terms. We can group the first 2 together and group the second 2 together. And like I said, grouping is kind of a part of this product sum factoring. That's why sometimes you'll see it as its own thing, sometimes you won't. From here, we just have 2 smaller common term problems, basically. So we have to look for, just at a specific set of parentheses, what can be taken out of each. So here, I can take a 2 away from both. And remember, I have to leave room for a leftover. I'll have a 2 divided by 2 is 1. Same thing over here. How many j's can I take out? This has 2, but this one only has 1 to give, so I can only take out 1 out front. So this still has a j left over, where this one we took away, it's only j. We move over to our second group, leave room for the leftovers. We can take a 7 out of both, but we can't take any j's away because this doesn't have any to give. So we're going to be left over with 1j plus 1. If we notice, there's kind of a self-check step in here that this inside stuff should work out to match after we do that. And the reason is, we've done all of our calculation at this point. We just have to build our factors, and that's going to be one of our factors. So we know when we have factors, it's things that are multiplied together. So I set up kind of a template, 2 sets of things multiplied together. One of them is going to be filled with the stuff that matches on the inside. So it doesn't matter which one you put that in. I just talked about it first, so I put it in the first set of parentheses, could have put it in the other one. Multiplication order doesn't matter. Doesn't really matter if you flip-flop those. We're going to build our second factor from the leftover stuff, from the stuff we factored out. 2j plus 7. So now we have two factors. And remember, we can always check, and we should end up with what we started with. If we were to distribute back, we should get this as a solution after distributing. So just real quick, I'm not going to show it or anything like that, but just to talk through it, 1j times 2j, 2j squared, 1 times 7, 7, but we also have 1j times 7 and 1 times 2j, where we would get those two separate terms. If we put those back together, we get the middle term, so it does work out for us. The second one over here, we'll jump, and we'll do this one a little bit quicker because it has a lot of the same steps. Product this time, 2 times -5, -10. Remember, sum is just the middle term, so a 3. If I were to list all those, I would remember to include negative and positive versions. I have to think about what multiplies to get -10, but adds to get 3. So I'm thinking here I'm going to go with a +5 and a -2. So I'm going to rewrite this, except the middle term split up again. 2w squared, let's say -2w plus 5w minus 5. So I just split this into these two things. I should point out, if you were to put it in the other order, it should still work out. Sometimes we can look at it and make our groups easier on ourselves though. Speaking of groups, that's where I'm going next. I'm going to have 2 sets of parentheses and then 2 small common term problems. So I can pull a 2w out of each. Have w minus 1 left over on the inside. Can take a 5 out of each of those. Have w minus 1 left over on the inside. Again, self-check, those match, so I don't need to go back and fix anything. I'm building my template. I know factors means I have things that are multiplied. I have something that's the inside. Remember, it doesn't matter what order. And the stuff that we factored out of the common term step builds our second factor. So the difference with the second one is I just wanted to kind of quickly show that this can be negative. The sum could also be negative if this was subtraction instead. We're allowed to use a negative and a positive to get there, like we did here. If this would have been, say, a -3 instead, we would have maybe flip-flopped and had +2 and -5, and that would have brought us to that answer instead. So hopefully this one was helpful. Kind of a step-by-step and then a lot quicker with just a twist to it. Let me know if that helped.